Hi, my name is Jeff Shantz, and in this video, I'll take you through the process of installing and configuring a Jenkins continuous integration server on Amazon EC2, and we'll do it all from scratch. Now, I will assume for the most part that if you're watching this video, you probably already know about continuous integration, and therefore I won't spend a whole lot of time extolling its virtues. But just in case you are new to continuous integration, I'll just take a few minutes to briefly describe it. So to understand the need for continuous integration, we'll first imagine a scenario that's actually fairly common in software development. We have a few developers working on a project, each of them goes off and implements individually a few classes, so they code them up, they write all sorts of unit tests to ensure that their classes work properly, and at the end of it all, they're patting themselves on the back, thinking that their program is going to be very, very robust because their classes are so well tested. But then they go to integrate the classes. They combine them together to create the larger program that the team is developing, and suddenly everything breaks. Code fails to compile, all sorts of bugs arise, and this situation has come to be known as integration hell. And it's essentially the time near the end of the project when we've finished all of our individual components and now we're trying to integrate them together and suddenly nothing works. Now, integration hell is a real problem for software projects, and it's very risky to their success. The reason being that while we may be able to come up with reasonable estimates of how long it will take to code up this class or code up that component, it's a lot harder to estimate how long it's going to take to fix things that go wrong. In other words, it's hard to estimate in the face of uncertainty. We have to start by figuring out, well, what's wrong in the first place? And that can be very hard to do in a large project. And then once we've diagnosed the problems, we have to spend time fixing them. So we may end up wildly going over our allotted budget or our schedule, and it can be very risky to the success of our project. So somewhere along the way, the folks that came up with the extreme programming methodology suddenly realized that, hey, so many software projects are failing due to integration hell, maybe a better way would be to integrate continuously throughout the entire project. And they therefore came up with the practice of continuous integration, or CI. So rather than waiting until all the components are developed and then spending weeks or even months working out the bugs that will inevitably arise when components are integrated on a project, CI says that we must integrate early and we must integrate often, and indeed it actually goes so far to say that we must integrate upon every single change. So every time a developer pushes new changes to the repository, then ideally the project code should be checked out, it should be built, in other words compiled, and all of its tests should be run. And this way, a team can ensure that the components being developed for a project interoperate correctly, and the team doesn't have this cloud of uncertainty looming over its head, knowing that it's going to need to spend weeks or possibly even months at the end of the project getting its components to integrate properly. Now, of course, if one is to rebuild a project and run all of its tests each time changes are pushed to the project repository, then the entire process is going to need to be automated. And this is exactly the purpose of a continuous integration server. So typically the process will work something like this. A developer will push changes into the repository, so maybe a GitHub repository, for example, and somehow the CI server will be notified of those changes. It will either pull the repository every few minutes to see if any changes have been pushed, or the repository will actively call the CI server to let it know when a change is available. So whatever the case, when the CI server sees that changes have been pushed to the repository, it will clone the repository on the server, or it may actually instruct a set of build servers to check out all of the code and then build the project. And if the project fails to build, it will send a notification to the team, usually via email. But assuming that the project does build, it will run all of the project's tests. And if any tests fail, it will then again send a notification to the team. And then finally, the CI server will usually generate various reports, such as the line coverage of the project's tests, or maybe a report on style issues that were found in the project's code. Of course, developers should be running tests on their code before they check it into their project repository, because we never want to be that guy who breaks the build. So why do we need a CI server if we're running our own tests? Well, first of all, a developer might just forget to run the project's tests before checking in his or her changes. On the other hand, the CI server will never forget, so any problems in the code will still be caught even if our developers forget to run their tests. Secondly, on even a modestly sized project, to run all of the tests in the project could take anywhere from, say, 30 minutes to maybe all night long, many hours. And therefore, requiring a developer to run all of the project's tests before checking in changes is often going to be infeasible. So it's useful to have a separate system on which all of the tests can be run, and that system, of course, is the continuous integration server. I wrote a web project recently that had about 15,000 lines of code. Not a huge project, but reasonably sized. So about 15,000 lines of code, but it then also had another 15,000 lines of test code. And to run all of the tests in the project would generally take around 30 to 45 minutes if I was running them on my MacBook. So it just wasn't really feasible to run them on my own system. Instead, I let my CI server do it for me, and then I could continue working on my code while it ran the tests. And when it was finished, I would get an email letting me know whether or not the tests passed. If we're developing a multi-platform or multi-architecture program, we'll also need to test our program in all sorts of different environments. Windows on Intel 32-bit, Windows Intel 64-bit, Linux Intel 32-bit, Linux ARM 64-bit, and so on. So we can set up all of these different platforms and architectures that we need, and then the CI server can use them as build slaves. So if the CI server detects a change in the repository, it will instruct all of the build slaves to check out the latest version of our code, build it, run all of the tests, and then report back to it. Now, as we already discussed, beyond simply building and testing a project, a CI server is useful for generating reports about the state of the code. So we often want to keep track of metrics like the project's line coverage, which is the percentage of lines in a project's source code that have been executed by its test suite. Line coverage is by no means a perfect metric, but a high line coverage will generally indicate to us that a program has been tested thoroughly, and we can therefore be reasonably confident that it is free of defects. So having the CI server run the tests and subsequently generate reports on metrics like line coverage can provide very valuable insights to the team, and maybe also identify areas in which further testing might be required. Maybe it identifies a class where the line coverage is only 50%, and so we know that we need to go into that class and maybe write some more tests for it. Beyond test metrics, there are all sorts of other utilities that we often run on our code. There's a program called CheckStyle that we can configure to check our code to ensure that it adheres to the style conventions that we've adopted for a project. Another example is a utility called FindBugs, which performs what we call static analysis on our code to try and identify bugs in the code. Essentially what it does is look for bug patterns, pieces of code that are likely to be errors, and then it generates reports on those areas so that we can go in and examine them. So all of these sorts of utilities can be run automatically by the CI server every time we check in changes to the repository, which is going to help us to ensure that we're maintaining very high quality code at all times. Finally, we can also deploy artifacts. So for instance, on the web project I just mentioned, every time I would check in code to the repository, GitHub would notify my Jenkins server to let it know, my CI server, and my CI server would then check out my code, build it, and run all of the tests in the project. And if the test passed, then it would deploy my code out to a staging server. In other words, a server that was set up to be similar to my production server, but it was an environment that was always running the latest version of the site's code so that my beta testers could go on the site and they could play around with the latest features and give me feedback on them. Similarly, we might be working on a desktop application, and if all of the tests pass, we might want the latest version of the program to be uploaded to our company's website so that our customers can always get the latest stable build. With a CI server, we can accomplish this sort of thing very, very easily and in a totally automated fashion. So in this video, we'll see how to set up a continuous integration server on an Amazon EC2 instance, or in other words, a virtual machine. You may already know that Amazon operates the largest public cloud in the world, known as the Amazon Elastic Compute Cloud, or simply Amazon EC2. And it's a quick, inexpensive way to get a server up and running. EC2 allows us to fire up an instance, a virtual machine, a virtual server in the cloud, and we can do whatever we want with it. You could put up a website in a few minutes, you could set up a mail server, and of course we can set up a continuous integration server. Now, there are a lot of CI servers out there, Hudson, Cruise Control, TeamCity, and so on. We're going to use Jenkins, which is one of the most popular CI servers out there. It's a very active project, it's updated often, and it's also free and open source. Its interface might not be the prettiest, but it provides a whole lot of functionality right out of the box, and it also has plenty of plugins that you can install to further extend its functionality. Now, one thing you may notice if you look up documentation on Jenkins on the internet, you may see a lot of references to Hudson. Jenkins originated from the Hudson project. It was forked from that project after Oracle took control of Hudson and the development team began to worry about how well Oracle would manage the project. So they forked the project and they released it under the name Jenkins. So in this video, we will set up a Jenkins continuous integration server on Amazon EC2. We'll start out by setting up an Amazon EC2 instance, or again, in other words, a virtual machine in the cloud. And once we have the EC2 instance set up, we'll install Jenkins on it, and then set things up so that GitHub will notify our server every time a change is checked into our project repository. Jenkins will then check out the latest version of our project code, build the project, run all of its tests, and then we'll have it generate line coverage reports so that we know how well tested our code is. Of course, if any failures occur when building or testing the project, we will configure Jenkins to email us to let us know about them. Now, for the purpose of this video, I'll be using a Java project in conjunction with the Maven build automation system, but you could use Jenkins to build just about any type of project as long as your build and testing process is automated. Now, before we get started, there are two things you'll need in order to follow along with this video. First, you'll need an Amazon Web Services account. From time to time, I get email from people on the internet asking me if I can create them a free Amazon Web Services account, and unfortunately, that's just not possible. Running Amazon EC2 instances costs money, so it's not possible for me to provide accounts to people other than my own students. Amazon has very generously given me a grant to use for a course that I'm teaching, but the funds in this grant are specifically earmarked for my students only. So you will need your own account, and I cannot create one for you. I'm sorry about that. The good news is that Amazon offers a free tier, which essentially means that you can run an Amazon EC2 instance for an entire year and not pay a single cent. So if you're interested in taking advantage of that, you can visit aws.amazon.com/free. The other thing you'll need is the hostname of an SMTP server so that we can configure Jenkins to send email. If your SMTP server requires a username and password, which most SMTP servers will these days, then you'll want to have that information handy as well. So, assuming that we have these two items, let's get started.